This is question number 37, the last one from the June 2017 Algebra 2 exam. So in this question, there's three parts. The first thing we need to do is write an equation in the form here. So we're told that A is the mass T hours after 3 p.m. So that would be 100 grams at 8 p.m. So we know that A is going to be 100. We know that A sub 0 is the initial mass, and we're told that it initially has a mass of 140 grams. So that is our A sub 0 value. And then we're multiplying that by 1/2 to the power of T over H. Now we know that T represents the time, T hours after 3 p.m. Well, 8 p.m. is 5 hours after 3 p.m. So in this case, it'll be 5. And it's going to be over H, which we don't know yet, the half-life. Now that fun part is saved for part 2 of the question, where it tells us to use the equation to solve for H. I'm going to start by dividing everything by 140. And by doing that, this will be canceled out, and we'd have 100 over 140 equals the rest of that, 1/2 to the power of 5 over H. And then we can just simplify 100 over 140 a little bit. We can take those zeros out. 10 over 14 is the same thing as 5/7. So now it's a little bit simpler. We have 5/7 is equal to 1/2 to the power of 5 over H. Now, because our variable is in the exponent here, we're going to use that trick where we take the log of both sides of the equation here. So if we take log of this and log of this, that's okay, we can do that. And that's useful because now we can use that trick where we take this exponent and flip it over to the front. So let's see what that would look like now. If we take log 5/7, it's going to equal 5 over H multiplied by log of 1/2. So now we just need to isolate H completely. One thing we can do is, like, imagine on the right-hand side, this is one long fraction, right? Where the numerator is 5 log 1/2, and our denominator is H. So what we can do is essentially flip the position of H and log of 5/7, and by doing that, we'll now have H completely isolated. So we'll have that H is equal to, I'm just going to zoom in here because I'm kind of running out of space. So H is going to equal 5 log of 1/2 over log of 5/7. And when you type that into your calculator, you should get an answer of 10 point, and we're rounding to the nearest 10 thousandths. So 10.3002. Now, for the third and final part of the question, we are asked to determine when the mass of the substance will be 40 grams. So now we're being told that the final mass, so the capital A here, will be 40, not 100. And we don't know the value of T. That's what we're trying to find, right? We're trying to find the amount of time. So it'll be T over our half-life, which we just calculated to be 10.3002. So we're going to be using a pretty similar strategy as the last problem to solve for T. I'm going to start by dividing everything by 140. And that'll cause that to cancel out. And 40 over 140 simplifies to being 2/7. So we'll have 2/7 is equal to 1/2 to the power of T over 10.3002. And then again, as before, we're going to take the log of both sides here. And then we can take this exponent and move it up to the front. So we'll have log of 2/7 is going to equal t over 10.3002 multiplied by log of 1/2. Okay, so now at this point, to get t completely by itself, we're going to have to multiply log of 2/7 multiplied by 10.3002, and then divide it by log of 1/2. And by doing that, we'll get t completely isolated. So let me just zoom in here and write that out. Okay, so we're going to take log of 2/7 multiplied by 10.3002, and then divide that all by log of 1/2. And that's what t is going to be equal to. And after you type that all out, you get a final answer of 18.6 if we're rounding to the nearest tenth of an hour. So I guess it would be 18.6 hours properly. Cool. So a pretty lengthy question. I hope that you were able to follow along. And that is it for this question. Thanks for visiting JD's Regents Preparation.